Hello everyone, welcome to the session Fundamentals of C and Programming. In this short video, let us explore memory organization using C program. To know why memory is organized, it is important to understand difference between a program and a process. Program is a set of statements or instructions written in a high level language. It includes header files, variables, declarations and initializations, function definitions, macro definitions, etc. Whereas a process is the running instance of an application. For example, you have written a program in a file and compiled it to generate an executable which is in machine level language that a CPU can only interpret or understand. When you run this executable, a process is created in the memory. From the CPU's point of view, the memory layout of the process is done in this fashion, where a memory is segregated into stack section to hold the arguments of the function, its local variables, its return value, etc. When you use malloc, calloc, realloc, dynamically, memory allocation happens in heap section. Global variables which are uninitialized, allocation happens in block started by symbol. Global variables which are initialized, allocation happens in data segment. For the program, the machine level language version or the opcode version is stored in text section. So this is an overview of memory organization. Let us move on to memory architecture. In real world, we have two basic architecture. One is von Neumann and another is Harvard. This architecture specifies how and from where the CPU is going to fetch code and data. For example, in von Neumann architecture, CPU fetches data and code from the single memory source with single bus interface. Whereas in Harvard architecture, the data and code are accessed from two different sources with two different bus interfaces. In real world applications, desktop versions use mostly von Neumann, and in embedded systems, we use mostly Harvard architecture. Moving on to memory hierarchy, which determines the performance and efficiency of a program. Here, the CPU is going to access the data in this hierarchy. Here, registers comes first, next cache or TCM, then main memory and secondary memory. Example, when CPU executes load or store instructions, it make a request to the cache controller to check the availability of the data. In case if data is available, it is loaded into CPU registers for execution. In case if the data is unavailable, then a request is made to main memory.